Alright, for this example we are going to look at an equation that has a fraction in it, okay? We're going to follow the same steps that we did before. However, with this fraction things are going to change a little bit. Right now I want you to think about what the bottom of this fraction is and how to get that number out of the bottom, or eliminate the fraction altogether. So that being said, let's get started. Our step one is still going to be the same. We're going to convert each equation to standard form. And let's start with the top. In order to convert that to standard form, we'd have to take this minus 12x and move it to the other side by adding it to both sides. Remember, put the x term before the y term so it's in standard form. So we'll have 12x plus 9y equals negative 27. Next up, we will convert the other equation to standard form. We will actually have to add y and subtract 6/5 x from both sides in order to get both these on the left. And remember, always put your x term first. So we'll start out with negative 6/5 x plus y equals negative 3. Here's what I was talking about. Because this is a fraction, in order to get it to standard form, you want a and b to be whole numbers or integers. So in order to convert negative 6/5 to an integer, just multiply the entire equation by 5. We're allowed to do that because we're multiplying the left and the right side of the equation by 5. And remember, we can do that because of the property, the multiplicative property of equality. You can multiply both sides by the same number. So if we multiply 5 times negative 6/5, that's just negative 6. The 5's cancel. Then we'll get 5y negative 15. So now we've got the other equation in standard form, and we can move on. So when we put both of those equations together, we have 12x plus 9y equals negative 27, and negative 6x plus 5y equals negative 15. We've converted both equations to standard form. And remember, step 2 is to fill in missing coefficients, but in this case everything is filled in. Okay, now we're going to determine the least common multiple of the coefficients. In this case, I chose x. Most of the time we choose x. Usually the simpler the better. I notice that 6 goes into 12, so the LCM will be simple. Whereas over here, you know, it'd be 45, which is a little bit bigger if we did the LCM of the y's. So the LCM is 12. That means that I'm going to have to take my bottom equation and multiply by negative 2 so that this becomes positive 12, my LCM. So I'll have to take negative 2 and multiply each of these. Negative 2 times negative 6 is 12. Negative 2 times 5 is negative 10. Negative 2 times negative 15 is positive 30. Alright, so there's the bottom equation converted so that the coefficient of x is the LCM. So here's my two equations. And I told you guys there's a shortcut here, which is pretty nice. Let's read steps 5 and 6 real quick. It says multiply the second equation by negative 1 and then add the equations. Those are the two steps, right? Multiply by negative 1 and add the equations. And a shortcut that I found out that works really good is just subtract the second equation. That's the same as multiplying by negative 1 and adding them. So that combines steps 5 through 6. Just remember to distribute the minus sign. So when I subtract the second equation from the first, it'll be 12x minus 12x. It goes away like we want. That's why it's called elimination. 9 minus negative 10y becomes 9 plus 10y, 19y. And then I distribute the minus to the 30, so it's negative 27 minus 30 becomes negative 57. So again, it's the same thing as multiplying this by negative 1 and adding it. And I get 19y equals negative 57, sorry. So there's that. That combines 3 steps in 1. I like that shortcut. Then we're going to divide both sides by 19, and we get y equals negative 3. So that's solving for a variable. Now we have to solve for the other one. So we're going to plug the variable into the equation. And why is it not showing that step? I wonder. Give me a second. Okay, so here's the step where we're plugging negative 3 in for y. Had we solved for x first, then we'd be plugging in for x. So step 9 is just plugging that number into the equation, and now we're going to solve for x. Alright, in order to do that, that's going to become negative 27. And then we will see that once 9 times negative 3 is negative 27, those will cancel from both sides since they're the same, so we get 0 equals negative 12x. Divide both sides by negative 12, x equals 0. And that's it. And then, like I said, sometimes I like to write them both next to each other. Again, when you solve a system of equations, you solve for both x and y. And if you have time for step 12, you can plug those back into both equations to make sure they work. So you have to plug it into both the x and y, both in top and bottom, to make sure that the equation balances out. If you have any other questions on solving two variable systems by elimination, let me know.